x by a plus y by b plus z by c is equal to 1. So this is the equation of a plane in intercept form. And when I convert this into the Cartesian form, we know that Cartesian form is a1x plus b1y plus c1z is equal to d. By writing the vector form and its normal, so evaluate the value for lambda. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So in our previous session, we have learnt the equations of line as well as plane in three-dimensional axis. And today we are going to learn the equations of plane based on different conditions. So the very first one is intercept form of the equation of a plane. That is, when the plane touches all the three axes x, y and z, what will be the equation of a plane? And the second one is plane passing through the intersection of two given plane. So when a plane is passing through intersection of other two planes, what is the equation we can write? And the last one is the coplanarity of two lines. So when I say coplanar, the two lines must lie on the same plane. So let's see the different equations of plane as well as the condition of coplanarity of lines in this session. So the very first is intercept form of the equation of a plane. So as already said to you, whenever any plane intersects x-axis, y-axis, z-axis at some intercept or at some point, then at x we can write it as a 0, 0, 0, where a is the distance of point from x-axis and the other coordinates will be 0 on x-axis. And 0, b, 0 on y-axis, because except y, other coordinates will be 0. And the z-axis is 0, 0, c, because on z-axis, the value of x and y will be 0. So these are the coordinates when the plane touches the three-dimensional axis. Then how to write the general equation? The equation of a plane is given by x by a plus y by b plus z by c is equal to 1. So this is the equation of a plane in intercept form. So let's solve the questions on this equation of a plane. First one, find the intercepts cut off by the plane 2x plus y minus z is equal to 5. We know that the equation of the plane in intercept form is x by a, y by b, z by c is equal to 1. That is, on the right hand side, the value must be equal to 1. But here we have the value is equal to 5. So what I'll do here, I'll divide the complete equation by 5. So then I'll get 2x plus y minus z is equal to 5 I have. I'll divide the complete equations by 5. So then I'll get x 2x by 5 plus y by 5 minus z by 5 is equal to 1. Now again I need only x in the numerator, then I can write this as 5 by 2 plus y by 5 minus z by 5 is equal to 1. So therefore, we are supposed to write the intercept. What is x-intercept? 5 by 2. What is y-intercept? 5. What is z-intercept? 5. That is, A, B, C is nothing but your x-intercept, y-intercept and z-intercept. So therefore, here x-intercept, y-intercept and z-intercept. So that is equal to 5 by 2. And here we need positive sign. So to make it positive, we will write this as minus 5 here. So because the general equation is positive, x by a, y by b, z by c. So therefore here the y-intercepts become 5 and the z-intercept becomes minus 5. Next question. Find the equation of the plane with intercepts 2, 3 and 4 on the x, y, z axis respectively. So here the intercepts are given. We are supposed to write the equation of a line. So what will be the equation of line? That is x by 2 plus y by 3 plus z by 4 is equal to 1. So, because 2, 3, 4 are the intercepts on x, y, z axis, hence the equation of the plane is x by 2 plus y by 3 plus z by 4 is equal to 1. Next one is plane passing through the intersection of two given planes. So, as I said, we have two planes here which are intersected. Let me call pi 1 as one plane, pi 2 as another plane. I am intersecting one more plane, pi 3, between these two. Now, I need to write the equation of this plane. So, that is the equation of a plane passing through the intersection of two planes. Okay. So, here this is one plane, this is one plane which is intersecting, and I am inserting one more plane which is passing through the intersection point of the other two planes. Then what is the vector form and Cartesian form of these equation of plane? The vector form of this equation is given by r dot n1 cap plus lambda n2 cap is equal to d1 plus lambda d2, because pi 1 be the plane and its equation be r vector r dot vector n1 is equal to d1, and let pi 2 be the another plane, and let its vector form of the equation is again r dot vector n2 is equal to d2. So, these are the vector equation of these two planes. Now, therefore, the vector equation of pi 3 will be in the form of r dot n1 plus lambda n2. So, that is here n1 cap is the unit vector of vector n1 and n2 cap is the unit vector of vector n2 is equal to d1 plus lambda d2, that is d1 and d2 is the distance of normal. So, therefore, here this is the vector form of the equation of a plane passing through the intersection of other two planes. And when I convert this into the Cartesian form, we know that Cartesian form is a1x plus b1y plus c1z is equal to d. So, here let a1, b1, c1 be the direction ratios of the normal, and we know x, y, z. So, therefore, here Cartesian equation here is a1x plus b1y plus c1z minus d1 plus lambda into a2x plus b2y plus c2z minus d2 is equal to 0. So, both represents the equation of plane pi 3. So, here we have the vector form and here we have the Cartesian form of the equation. Next, find the equation of the plane passing through the intersection of the planes 3x minus y plus 2z minus 4 is equal to 0 and x plus y plus z minus 2 is equal to 0 and the point 2 comma 2 comma 1. We need the point of intersection also from which it is passing. So, therefore, here, so let me use the Cartesian form of the equation of writing the equation, that is a1x plus b1y plus c1z minus d1 plus lambda into the second plane is equal to 0. So, thus the equation of this plane can be written as 3x minus y plus 2z minus 4 plus lambda into x plus y plus z minus 2 is equal to 0. Now, since the given plane is passing through the point 2 comma 2 comma 1, I can replace the value of x, y, z as 2, 2 and 1. So, therefore, here 3 into 2 minus 2 plus 2 into 1 minus 4 plus lambda into 2 plus 2 plus 1 minus 2 is equal to 0. So, here I have 6 minus 2 plus 2 get cancels, 6 minus 4 plus lambda into, again here 2 plus 2 4, 5 minus 2 which becomes 3 is equal to 0. So, I will get 2 plus lambda 3 is equal to 0, or I will get 3 lambda is equal to minus 2 or lambda is equal to minus 2 by 3. So, we know now the value of lambda is equal to minus 2 by 3. Let us substitute back to the same equation. So, therefore, the equation of the plane is 3x minus y plus 2z minus 4 plus, what is the value of lambda we have? We have lambda is equal to minus 2 by 3. So, minus 2 by 3 into x plus y plus z minus 2 is equal to 0. So x plus y plus z minus 2 is equal to 0. So we can also solve here. So multiply 3 to the whole equation. Then we have here 9x minus 3y plus 6z minus 12. So when you multiply 3, it becomes cancelled. So we have minus 2x minus 2y minus 2z plus 4 is equal to 0. So is equal to 0. Solve the corresponding variables here. 9x minus 2x is 7x, minus 3y minus 2y minus 5y, plus 6z minus 2z plus 4z, minus 12 plus 4 is minus 8 is equal to 0. So this is the required equation of the plane. So next we have, find the vector equation of the plane passing through the intersection of the planes r dot I plus j plus k is equal to 6 and r dot 2i plus 3j plus 4k is equal to minus 5 and the point 1, 1, 1. So clearly they have mentioned you to find out the vector equation. We know that vector equation is r dot vector n1 plus lambda vector n2 is equal to d1 plus lambda d2. So now here let me keep r as it is. So vector n1 is I plus j plus k plus lambda into vector n2 is 2i plus 3j plus 4k is equal to d1 is 6 minus lambda 5 because d2 is minus 5. Now let us solve this. Let us take r as xij. So let me write here r as it is first. So here I have 1 plus 2 lambda I plus, next I have 1 plus 3 lambda j plus 1 plus 4 lambda k cap is equal to 6 minus 5 lambda. Now let me take r as xi plus yj plus zk. So this is our r. So since we have here dot product, let me multiply it. So dot product, we know that a1 b1 plus a2 b2 plus a3 b3. So similarly we get here 1 plus 2 lambda into x, 1 plus 3 lambda into y, 1 plus 4 lambda into z is equal to 6 minus 5 lambda. Now they have given here the plane is passing through the point 1, 1, 1. That means the coordinates of x, y, z is 1, 1, 1. So by putting the value of x, 1, y, 1, z, 1, we will get 1 plus 2 lambda, 1 plus 3 lambda, 1 plus 4 lambda is equal to 6 minus 5 lambda. So solve this. 2 lambda plus 3 lambda, 5 lambda, 5 lambda plus 4 lambda, 9 lambda. 9 lambda, 1 plus 1, we have 3 plus 3. So let me write here. So you will get it as 6 minus 5 lambda. So solving for lambda, we have 9 lambda plus 5 lambda is equal to 6 minus 3. 9 plus 5 is 14. So 14 lambda is equal to 3 or lambda is equal to 3 divided by 14. So this is lambda. Now we got what is lambda here. Just write as it is the equation substituting the value of lambda. So the equation becomes vector r dot I plus j plus k plus lambda. Lambda is 3 by 14 into 2i plus 3j plus 4k is equal to 6 minus 5 into lambda, which is 3 by 14. So therefore, we get r dot. So here I can also write this in the form of I plus j plus k plus 3 by 14 2i plus 3j plus 4k is equal to, on solving, 69 by 14. Now let me multiply 14 for this one. So let me keep r as it is, r dot. So here I will get, when I multiply 14, I'll get 14i plus 14j plus 14k, plus when I multiply 14 here, so it cancels. So next I'll get 3 2s are 6i plus 3 3s are 9j plus 3 4s are 12k is equal to 69, because I have multiplied the equation completely by 14. Again this is equal or dot. 14i plus 16i is 20i. 14j plus 9j is 23j. 14k plus 12k is 26k is equal to 69. So this is the vector form of the required equation of the plane. So by writing the vector form and its normal, so evaluate the value for lambda. So once you got the value for lambda, substitute it back to the general equation and evaluate and find the equation for the plane. Next, coplanarity of two lengths. So as I said, when I say coplanar, that means it lies on the same plane. So here I have taken two straight lines. One is A and one is B here. So they are in the same plane. Now to show that they are in the same plane, we have a general formula, that is the scalar triple product with respect to their vectors and the dot product of their coordinates. So that is, if line A, say point A, it is passing through the point A, then the equation of line is given by r is equal to vector A1 plus lambda into vector B1. Say another line which is passing through B and its vector equation is vector r is equal to A2 and mu B2. That is, both are vector, and then we say that they are coplanar if and only vector AB is perpendicular to B1 cross B2. What is this vector B1 and B2? Vector B1 is a vector parallel to line A and vector B2 is a parallel line which is passing through point B. So if B1 and B2 again are another two vectors, then a line passing through AB, or we can say vector AB, must be perpendicular to the cross product of B1 cross B2. That is another vector when you take the cross product of B1 cross B2. So therefore, if B1 is one vector and B2 is another vector, there will be one vector which is perpendicular to both B1 and B2. So that is why this vector is called as B1 cross B2. And this vector must be parallel to the line AB. And that is what the condition of a two lines which has to be coplanar. And that is given by vector AB dot B1 cross B2 is equal to 0. And we know that AB is nothing but OB minus OA. So therefore, we can find their coordinates, and hence we will write it as A2 minus A1, whose vector A2 minus vector A1 dot B1 cross B2 is equal to 0. So which is a scalar triple product. We can see dot and cross, and this is called a scalar triple product. So thus, if the scalar triple product of the vector AB and B1 cross B2 is 0, then we can say the lines are coplanar. And in Cartesian system, we can write it in the determinant form. We have already seen in the vector chapter. That is, a scalar triple product can be expressed in terms of a determinants. And here is x2 minus x1, y2 minus y1, z2 minus z1 for the first row, because we have vector A2 minus vector A1 for AB. And B1, B2 means write their direction ratios, A1, B1, C1, A2, B2, C2. Show that the determinant will become 0. Then we can say the two lines are coplanar. So let's take one problem. Show that the lines x plus 3 by minus 3, y minus 1 by 1, z minus 5 by 5, and x plus 1 by minus 1, y minus 2 by 2, z minus 5 by 5 are coplanar. So we can either show by with the help of the vector form as well as the Cartesian form also. So here it is given in the Cartesian form. So let us write all the variables needed. So let me write first x1. So x1 is here minus 3, y1 is 1, z1 is 5. Next I will write A1, B1, C1. So A1 is minus 3, B1 is 1, C1 is 5. Next I'll write x2, y2, z2. x2 is minus 1, y2 is 2, z2 is 5. Next I'll write A2, B2, C2. A2 is minus 1. Next B2 is 2, C2 is 5. Now let me take x2 minus x1. x2 minus x1 means minus 1 minus of minus 3 is plus 3, which is 2. Next I will take y2 minus y1. y2 minus y1, 2 minus 1, 1. z2 minus z1, 5 minus 1, 0. So since the equations are given in Cartesian form, let me take the Cartesian form of the scalar triple product. So let's show it. The value of the determinant is 0. So now consider x2 minus x1, y2 minus y1, z2 minus z1 in first row, that is 2, 1, 0. Next we will take a1, b1, c1. So a1 is minus 3, 1, 5. Minus 3, 1, 5. Next a2, b2, c2, minus 1, 2, 5. Minus 1, 2, 5. Let's evaluate the determinant. So equals 2 into 5 minus 10. Minus 1. So minus 1 we have minus 15 plus 5 plus 0 we have. 0 into anything is 0. So we have here 5 minus 10 minus 5. Minus 5 2s are minus 10. Minus 15 plus 5 minus 10. Minus 10 into minus 1 plus 10. So plus 10 minus 10 cancels. So 0. So therefore we can conclude the lines are coplanar. So this is how we are going to prove the lines are coplanar. So here we can use the scalar triple product even both in vector form as well as Cartesian form. So we'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.